Now, let's talk about some example when you have the term which are variable x, y, and z. Okay, but anyway, we still apply the same rules again for the exponents. Okay, the first rule is when you have the same base for both terms x and x, right? In this case, you just add up the power together, right? You're going to get power m plus n. Or in the case when you have x to the power m divided by x to the power n. In this case, you just take the subtraction between the two powers. All right. Or in the next rule, if you take the power twice, in this case, I'm sorry, let me write it out again. When you take the power twice, in this case, you just multiply the power together, m times n. All right. Or if you have the term of x, y inside, and then you put the power of n outside, here you just give the power of n to everything inside parentheses. All right. It is similar to the case when you have x or y, and then you take the power n outside. Okay. So here, let's do the first problem right here. Okay, I can give you one more rule. In the case when you have the negative power, all right, whenever you see the minus sign, all right, you need to get the reciprocal. You need to do the flipping upside down. Okay, so here you're gonna get 1 over x all right, because here you can take okay, for this rule here there are some other rules. Okay, if you have x to the power minus n, you can put it to be the reciprocal. All right, or if you have x or y, then you put the power minus n outside. Okay, for the minus sign, it means that you need to do the flipping upside down. So here you need to get y over x and then put it to be the power n. Okay, so here, this is the case when you see the minus sign for this power. All right, so it means that you need to do the flipping upside down between these two terms. So this will give you, let me put it down right here. The first term will be the same. Or you can combine the term together, all right? Here. For the top term, you have x to the power 3, and the term at the bottom, now you have x to the power 1. All right. In this case, you get the same base of x and x, right? So in this case, you can combine the power together. But here, you need to do the subtraction between the two powers. Right, so actually, you get 5 over 3 x to the power 3 minus 1. All right. The next term, the term y. You can put it to be y squared again. All right. It is because you don't have the term y in the numerator. But for the next term of z, now you can have z to the power 1, all right, divided by z squared. So you put it to be z to the power 1 minus 2, all right? And then now you can do the flipping upside down between these two terms because you see the minus sign here, all right? So you're going to get 27x over 25 y to the power 5 c to the power 1. And then you put the power 4 outside. Okay. And then for the number of 27, okay, let me do it. Starting with the first term, you have 5 over 3 x squared z to the power minus 1, right, divided by y squared. All right, and then if you look at this term, all right, now you can give this power, the power 4, to everything inside this parentheses. Okay, and then for the number of 27, it can be 3 to the power 3, right? 27 is from 9 times 3. 9 is from 2 square. So totally, you have 3 terms of 3. Right? You have 3 repeating terms of the number 3. And similarly, for 25, you can put it to be 5 square. All right? And then when you give the power 4 to everything, right? So this will become 3 to the power 3. Sorry. Then you put the power 4 again. Right? The next thing will be x to the power 4 over 5 square to the power 4, y to the power 5, put the power 4 again, z to the power 4. All right, and then in the last step, here for this term, it is a case when you take the power twice. All right, so here just multiply the power together. So this power will become 12. And it is similar to this term. All right, you have the power of 8 and then the power of 20. All right, so this will give you 5 over 3 x squared z to the power 1. All right, here try to combine the term that are the same or the like term. Okay, for example, here you have z and z. Okay, so when you combine the two terms, you get the power minus 1 minus 4 again. All right, the next term you have 3 to the power 12 x to the power 4. So let me combine with x squared. This could be plus. All right, and then the next thing is the term of, okay, we also have the term of number. You have 5 to the power 8. Okay, and then you have y to the power 2 plus 5, sorry, plus 20. So that's it, right? And then the next thing is we can combine the term of number. All right, you have 5 to the power 1, 5 to the power 8. So here you have 5 to the power 1 minus 8, 3 to the power 12 minus 1. Okay, and then x to the power 6 about y? If I move it up here, it's going to be y to the power minus 22. All right, and then z to the power minus 5. So at the end, you're going to get this answer. And then for the next problem, all right, here you can give this power to everything inside this parentheses. Okay, so this will give you 4x to the power 7, c to the power 4, 2 to the power minus 2, x to the power minus 2, y to the power plus 8. Right, it is because for this term, you take the power minus 2 again. So here you take the power twice, right? So just multiply these two power together. That's why you get y to the power 8. Right? And then you do the same thing to this term. You give this power to everything inside this parentheses. Okay? So here you will get 6 multiplied with x to the power minus 12, and then y to the power minus 3, z squared. Okay, and then for the next term, you have division or dividing. Okay, for a simple example, when you have 10 divided by 2, you have 10 over 2. All right, actually you get 5. Okay. So you can think about 2 to be 201. All right. So actually you can put it to be 10 multiplied with the reciprocal of 2, which is 1/2. That's why you get 5 again. Okay. So here, if you want to change from dividing to be multiplying, you need to get the reciprocal of the whole term. Right, make it to be 1 over that term. Or we just flip these two terms, right? Just flip them upside down. Okay, so in this case, you have multiplying, all right? And then first, you still get a fraction again, all right? But first, let's put this term to be the top term or the numerator. Okay, and then for this term again, right, you can give this power to everything inside these parentheses. Okay, so this will give you 18 square x to the power 5, and then take the power 2 again. So you can get x to the power 10, right? And then y to the power minus 2, then z squared. All right, and then later on, now you put this term to be the term at the bottom or the denominator. Okay, so now you have 12 to the power 3 x squared y c to the power minus 1. Okay, and then you can try to combine all the terms together. Then how about for the term of number? All right, here we can break the number of 18 to be 6 times 3. All right, and for the number of 12 again, we can break it to be 4 times 3. What else can we do? Okay, so that's it. All right, so now you have 4 so now when you combine the power together, all right? Here you have 4 to the power 1, right? And then you try to combine with this term 4 to the power 3. So now you get just 4 to the power minus 2, all right? So now we already use this term, that number, all right? The next thing is, how about if we try to combine the number 3 together, all right? For this number 3, it is 3 square, right? It is from this power, right? So now you have 3 square. Then for this number 3, you have 3 to the power 3, right? So 3 square divided by 3 to the power 3, you get 3 to the power minus 1. Right, so now we already use this term. And then the next thing is the number 6. Okay, here you have 6 square because of this power, all right, divided by 6 to the power 1. So actually you have 6 to the power 1, or just 6. Times 6. Okay, how about for the term x? All right, here you have, let me see, the power of 7, right, plus 10, you get 17, minus 2, you get 15, minus and minus 12 again, so you get 27. Are you with me? All right, you have x to the power 7, x to the power 10, all right, and then when you flip this term upside down, all right, you need to get the power which is the opposite to the original power, all right. The original power is minus 12, so the new power needs to be minus or negative 12, so you can get plus 12. All right, and then the last term you have x to the power minus 2. All right, so actually you're gonna have, let me see, right, you have 17 plus 10, you get 27. And you also have the number of 2 as well, right? You have 2 to the power minus 2. Put it to be the first term. And then for the term y, what do we have? Right, you have this term, this term, this term, and that term, right? For this term again, when you flip it upside down, you need to get the power minus of this number, all right? Minus of negative 3, you get plus 3. So now you get y to the power 8 minus 2 plus 3, and then y to the power minus 1. Okay, so here you have minus 2 minus 1, you get minus 3, plus 3, you get the power of 0. So actually you get y to the power 8. But for the term z, okay, here you have, let me see, 4 plus 2, you get 6, right? Minus 2 again, you get 4, plus 1, you get 5. Right? And then later on, you can combine these two terms together. So what is it? What is it? All right. Here you can make 4 to be 2 square. Right, so actually you have 2 to the power minus 2, 2 square to the power minus 2 again. All right. And then for this term, when you take the power twice, right, just multiply the power together. So actually you get 2 to the power minus 4. So totally you get 2 to the power minus 6. So that's it.